Electronic devices play a huge role in our daily lives. They power our phones, our laptops, our social media. All of these devices become obsolete really quickly. So once we've used all our phones and our laptops, it's creating a very, very big problem. 50 million tons a year of electronic waste is produced annually, and that's equivalent to $60 billion of raw material value that we're losing every year. So recycling electronic waste, at the moment, there's really only one way that we do that, and that's a really highly intensive, highly pollutive process that relies on smelting. Smelting really is the use of high energy and temperature to recover the metals from electronic waste. We're effectively burning the electronic waste in what really is a cauldron of fire, and then recovering the metals at the end of that, which leads to huge CO2 emissions and particulate emissions, which lead to really poor health conditions. Compared to smelting, we're fundamentally different. First of all, we're lower energy. Second of all, we're lower carbon. And thirdly, most importantly, we have a low impact on the environment.
Compared to smelting, our process is significantly cheaper, is much cleaner, produces less CO2, does not produce metal particulates, and ultimately it ends the reliance on smelting. So our patent-protected technology is based on a novel class of chemistry called deep eutectic solvents, or DES for short. DES are eco-friendly, non-water-based liquids that can be operated at low temperatures. So the trick is that we design our DES to dissolve different metals at different times. So DES are simply made by choosing very carefully a combination of salts and organic compounds, and when mixed together in the right proportions, produce a unique liquid that are very, very efficient at dissolving the metals contained within e-waste. So e-waste that we're processing are typically come in the form of motherboards, memory units, and printed circuit boards. And before they enter the DES, we go through a shredding process to make the particles smaller. So the shredded e-waste is then added to a DES formulation, which then targets the copper, the tin, the zinc, the lead, the silver, palladium, and other base metals, and it specifically dissolves them out. And we can think of this a bit like dissolving sugar in your morning coffee. What is crucially left behind is gold, which is not dissolved in this formulation. The materials that are left behind that haven't been dissolved are filtered out and added to a separate DES. When this material now goes into a new DES, the gold is dissolved. The metals are simply recovered from the DES by using industry standard techniques. Ultimately, we produce a wide range of metal products that can be sold back to the industry and repurposed into brand new products.
So the next major step for DEScycle is to build and construct and operate our large-scale pilot, which we're going to be doing next year. This is really going to help us to scale up and show how technically and economically feasible the process is.
So we're implementing this by forming joint ventures with groups such as Gap Group, who are one of the UK's largest recycling organisations.
Partnership with DEScycle is really exciting to everyone at Gap. It's going to give us more innovation in our own processes that we currently possess. Recycling should be recycling, should be able to recycle as much as possible out of something.
At DEScycle, our technology truly has the potential to change the way that we recover metals. And ultimately, that's going to lead to a cleaner, healthier world.